Thank you very much, and thank you for giving us the opportunity to share this presentation with you. What I would like to share with you is, because in previous presentations we already heard some of the presenters talking about the Port of Rotterdam. So I would like to start with a short overview of the Port of Rotterdam, and then I would like to dive into the different fields of activities that we follow. So maybe just as a start, a glance of the Port of Rotterdam, and I'm not going through all the numbers of that you see on the slides, but I think for the topic of today, it's important to know that the Port of Rotterdam is the energy port for Europe. A little over 13% of all energy that is used in Europe passes through the Port of Rotterdam. 1/3 of all energy used in Germany passes through the Port of Rotterdam. And today, all this energy is, well, roughly all is fossil. So these numbers give us a real responsibility, because they also take account of a lot of carbon emissions. So it gives us a responsibility to deal with it and to fight climate change and to go to a carbon neutral port. So what we did was we did perform 2 really large studies together with industry. In 2017, we did a large study with industry to define pathways to decarbonize the industry in the port. And then 1 year later, we did the same study to define pathways on how to decarbonize transport from, for instance, China to Rotterdam, but also transport from Rotterdam to the hinterland in Germany or in Belgium or in France. So these studies together, they gave us an overview of actions that were needed. They gave an overview of existing technology that could be deployed, but also they gave an overview of what kind of innovations were needed in order to reach the climate neutrality targets that we've set for 2050. And this morning you've heard a lot of innovation that's going on, a lot of innovation that we're trying to get into the Port of Rotterdam and trying to get it into the various supply chains that run through the Port of Rotterdam. We've heard Maersk talking about bunkering biofuels. We've heard Vopak talking about liquid organic hydrogen carriers and developments around liquid hydrogen. Various partners from China talking about developments in electrolyzers. And what we try to do is get this all working together in an integrated approach. Some about the targets we've set and the ways in which we try to reach those targets. We defined a 4-pillar approach. This approach will lead us to 55% carbon reduction in 2030 and neutrality in 2050. The first pillar that we're working on, and I'll dive into them a bit more later on, the first pillar is around infrastructure development. Infrastructure in the port and infrastructure connecting the port to other industrial areas in Europe. The second part, the second pillar that we're focusing on, is the development of a new energy system. So moving away from coal, oil, gas as energy source and going into renewable energy. And this is where hydrogen plays a large role. The third element, the third domain of activities is around new feedstocks. So moving away from oil as a feedstock and going to waste as a feedstock, bio-based material as a feedstock, and maybe even carbon taken from the air as a feedstock. And then the fourth one is around transport, finding ways and pathways to create sustainable transport, both on sea as on land. Now let me take you briefly through the first one. And in this first one, you will see that we have 6 key infrastructure projects in development. Infrastructure projects that are focused on the development of infrastructure in the port for hydrogen. So we're building a pipeline connecting the far right end of the port to the far left end of the port for hydrogen. And the second one does more or less the same, but that not in the port, but connecting the port with other areas in Europe, even reaching all the way into Germany. We also will need a strong electricity grid in the future. We've heard about all kinds of possibilities around electrification this afternoon or this morning in Europe, and you need a strong infrastructure for that. The fourth one is around the development of a carbon capture and storage infrastructure, and that will run through the port and will give the possibility to store carbon dioxide in depleted oil and gas fields just offshore the port of Rotterdam. Residual heat. We have a lot of residual heat in the port of Rotterdam, and we have a lot of heat demand just outside the port. So why not connect these and make the system much more efficient? And finally, H-Vision is a project in which we can decarbonize refinery gases and make hydrogen out of them and use them for high temperature processes. So these are all infrastructure projects. I've put them on a map just to see. So you see the Portos project is the carbon capture and storage project, connecting the industry in the port with the depleted oil and gas fields. And then the others are the infrastructure connecting the different areas in Europe. I'll go to the second domain. The second domain is around the new energy system that we're trying to build. We focus on the development of wind in the port. We focus on the development of solar in the port. But if you look at these numbers, then we need to do them, but that's not enough. So hydrogen plays a key role in here. And for this hydrogen development, what we have set up is a program that really develops the whole value chain around hydrogen. So it starts with production of power offshore, connecting it to the port area, then by electrolysis making hydrogen. Could also be hydrogen that is produced offshore, like we've heard this morning, the project called by Neptune. And it will, if you can see on the line to follow all the elements that we're working on to develop this hydrogen value chain. Now, calculations that we've made show that we can probably get to 10% of what we need produced locally. So 90% of what we need in the future and as clean hydrogen will be import. So together with companies like Vopak, we have set up a strategy for import terminals for hydrogen. And if you talk about the volumes that we will need, then we made a calculation starting with the use of energy that's imported today in Europe, then defining what kind of efficiency measures can be taken, and then translating this into what amount of hydrogen will be needed in the future. And this adds up to a total amount of 20 million tons of hydrogen that will be needed by 2050. And we started with a program to really ramp up all infrastructure requirements that are needed. So the first announcements and the first developments for pipeline infrastructure, import terminal infrastructure are on its way. Also, Shell announced the production of, or the development of a first electrolysis site in the port of Rotterdam. So it's not just future planning anymore, it really took off. Now mind the difference, I'll get back, sorry. This was the situation before we had the situation with Ukraine, and now this is the situation after, because Europe decided to even move faster in its energy transition path. So that means that the end goal is still the same, but we need to ramp up faster than what we were used to before. Now also earlier in this seminar, it was talked about a lot about hydrogen and the different forms in which it can come to demand sites. Now we estimated that we would need 20 million tons of hydrogen. 20 million tons is the same as 130 million tons of ammonia, and so on. And it adds up like 56 million tons of crude oil. Today, the port of Rotterdam handles 100 million tons of crude oil. So here you can see that we really defined an efficiency pathway to go from 100 million tons of crude oil to an equivalent of 56 million tons of crude oil, and that changes into hydrogen. That is what we are aiming for in the future. I told you that we already started. Shell has started its production, is building its electrolyzer. It will be operational by 2024, latest early 2025. We will have the infrastructure operational by then, and you can follow all the way down what is planned until 2030. Really a large program, and it's really moving in the right direction. The third pillar, now I told you the first one was infrastructure, the second one was new energy, the third is around the feedstock transition. So moving away from fossil feedstock for industry. And what you need for this new industry is that you are looking for waste as a feedstock. So in order to get to circular industry. And what we also need is bio-based material as a feedstock. But this industry also needs hydrogen as a feedstock or as a high temperature process element. So here the strategy more or less falls together, and here you can see that we need the infrastructure, we need the hydrogen, and then we will able to change the industry. Two examples of what is being realized today in the port of Rotterdam. One is a project together with Shell and Enichem from Canada in the development of a facility that will turn waste into jet fuel. Another one is a large extension that Neste will realize in the port of Rotterdam. Neste, a Finnish company, and they will build a next facility that will turn bio-based material into jet fuel. An investment of almost 2 billion euros. And there are much more examples to share, but I won't do for a matter of time. I won't do it now. I will step to the fourth domain, and that is the domain of sustainable supply chains, clean transport. Earlier this seminar, we heard Maersk talking about all kinds of developments that are going on here. So I won't pay that much attention to the sea side of this. That was covered already by Maersk. And that is, as you can see, one of the most important if you look at the breakdown of emissions from the port of Rotterdam, because roughly, well, 90% of all emissions is related to deep sea shipping. And this is where we also need to work together internationally with, for instance, China, because the large shipping lanes run from China to Europe, and we need to work on both ends to really develop this. I have some examples of what already is working in the port of Rotterdam. At the far left, you see a shore power installation. You can see this offshore installation, and you can see the wind turbines in the back, and these are connected. So when this offshore installation is in the port of Rotterdam, it is connected to renewable power, and there are no emissions anymore in the port of Rotterdam. It's the first and the biggest of these kinds of installations worldwide. In the middle, you see an inland barge which is electrically powered. So we put on a battery which is loaded, the ship starts sailing, it enters port, it has an empty battery, it changes its battery, and it gets loaded, charged again with renewable power. This ship is running, it's running from the Heineken brewery in the Netherlands to the port of Rotterdam, and then shipping its containers all over the world. And the third one is really a simple one, but it's one that we really should take into account. It's just cleaning hulls of ships. And this can save you up to 15% of emissions just by having a clean hull. So just 3 examples of what is already running today. Now with that, I get to my, my last slide. And what I hope to have shown you, and what I have learned also this seminar, is that there's a lot of existing technology today that can help us, but there's also a lot of innovation going on that really can help us to reach our ambitions. So I would like to thank you for the information that you shared, and I hope that you also did learn a bit from what we from the Dutch side shared with you. For me, it was really interesting to learn what is going on in China, and I'm really looking forward to have a stronger relation on all these developments to fight climate change. Thank you for your attention.